my task now is to introduce my panel here beside me. And I'm going to start at the other end with Dale Sanders, who's the director of the John Innes Centre. He was appointed in 2010 as the director. Previously, he's from York, from the University of York, so this must just be like coming home. And a little-known fact about Dale, I've tried to find out little-known facts about everyone. Because it's quite fun, really. So a little-known fact about Dale is that he actually considered a career in plant ecology, but decided it was far too messy. Next to Dale is Mike Bushell, who is the principal scientific advisor for Syngenta, which is an innovation company. And he has been gone through a lot of different roles in Syngenta, and he's also secretary to their technology advisory board. He's also served on lots of external industry bodies, so he really is a representative of industry here and can teach us all something about that. And a little known fact about Mike is that he was once offered 150 bottles of wine and turned it down. Next along is Professor Mark Chase, who's the keeper of the Jodrell Laboratory at the Royal Botanical Gardens at Kew. That means the director, but in places like Kew and the Natural History Museum, people are keepers. And he is an American who received his PhD from the University of Michigan working on orchids. And then he went to North Carolina, and then he came to Kew in the early 1990s, about the same time that I came to the UK. And he's a fellow of the Linnaean Society and has been the publications secretary of the Linnaean Society, who's one of the member organizations of the UK Plant Sciences Federation. And he's interested in angiosperm phylogeny. And a little known fact about Mark is that his first degree is in Chinese history, which shows that you can go into plant science from almost anything. And then there's me, that empty chair is me. And my name is Sandy Knapp, and I work at the Natural History Museum. I'm the head of the Division of Plants Division, I think it's called now, at the Natural History Museum. And I work on tomatoes and potatoes and tobacco and anything in the nightshade family. And I'm an unreconstructed taxonomist, and I spend a lot of my time in South America looking for new species and looking at distributions of plants. And a little known fact about me is that I almost did my first degree in medieval French literature, which really does show that you can go into plant science from anything. And then Jim needs no introduction. He's the chair of the UK Plant Sciences Federation from the University of Warwick and was most recently the head of the Garnet Consortium. And he has done a marvelous job in chairing the executive and chairing the UK Plant Sciences Federation through its first couple of years. It's always hard to get something off the ground, and Jim has been a fantastic chair of the group, and we really, really appreciate it. And last but not least, here next to me is Sarah Gurr, who is the chair in food security at the University of Exeter. This chair was a post that was created by Exeter in association with the BBSRC and Rothamsted Research. And Sarah has only recently moved to Exeter. Before that, she was at the University of Oxford. She's interested in fungal diseases of plants and is particularly interested in their global movement and control. So she's really that person who understands how things work with plants that perhaps aren't really plants, although fungi used to be thought were plants. And a little known fact about Sarah is that she is was the Oxford shepherdess. Which you might have to explain. So we're going to allocate, each of us will maybe speak for, I don't know, anywhere between 1 and 8 minutes. That sounds pretty exact. And then we'll open up the floor. And I put up here behind us, so that everybody can be looking at these the whole time that we're all burbling on, is about those challenges from the report, so that you can think about those and think about what you would like to comment on, what we've left out, how we could pull these things together, ideas you might have, because the more people you get together to think about things, the more ideas you get. So I'd like to start with you, Sarah, please.
Okay. So thank you very much. I should explain I was the University of Oxford departmental shepherdess because the department opened in 1621 and it took them 400 and X years to appoint the first woman to faculty. Then they discovered they didn't have any money apart from this pot that had been accruing since the 17th century to pay a shepherdess. So there we are. Okay, so I want to talk about one particular challenge, an academic challenge, and I want to dress it up on 3 particular facts. So I want to talk about the threats and challenges posed by pathogens and pests. So I want to talk briefly about pests themselves, then I want to talk about modern agricultural practices, and then I want to talk a little bit about the way ahead as far as I can see it, which addresses some of these comments here. So I think everyone is aware that at the moment we lose between about 16 and 23% of our crops to disease on a year-on-year basis. That is despite mitigation and not during an epidemic year. And of all of the pests and pathogens that we have, it is the fungi and the oomycetes which cause the most damage. We also lose about 10% of our harvest post-harvest. It's something we don't really study very much. So very recently, we've undertaken 3 particular meta-analyses, and I just want to very briefly describe these because they set the scene, I think, for what we need to do in the future. So the first meta-analysis we undertook was using an untapped database from CABI for reports for observation of diseases around the world, which started in 1890 and which became robust in about 1960. And after all sorts of fancy statistics, we took the observational bias out, and we were able to see that pests and pathogens are moving poleward in a warming world, such that fungi are moving on average 8 kilometers per year polewards, northwards, and oomycetes almost 6. Now, this is going to severely influence our crop protection strategies, particularly towards the poles, and what we do over the next few years. So our next meta-analysis looked at different countries, and again, using all sorts of parameters, we looked at the pathogen load in each country, and we were able to see that only one country is relatively accurately in the world reporting how many pests and pathogens it has, and that is America. And if you come up with quite a sophisticated equation, you can feed this in to predict what other countries should have in terms of pest and pathogen load. So, for example, Burma, Myanmar, is underreporting by about 350 pests and pathogens. The UK, surprisingly, is also underreporting by about 150. And the only country in the world overreporting is France, which we assume is due to good claret at lunchtime. However, this is very, very serious. So our final analysis, which we hope is in press at the moment, was a correspondence analysis where we looked globally, and we can see that pests and pathogens have approximately stayed within a latitudinal range, which means that climate change will influence their movement. We've also looked at new pathogens and new demographies. We've also been able to predict not only when we think countries will saturate with particular pests and pathogens, but what those pathogens will be. And probably the most alarming figure, not yet published, is that the first crop to saturate with a pathogen or a pest is going to be the root knot nematode, and that is within the next 10 years, followed rapidly by the powdery mildews. So in a global perspective, we're beginning to see how we should move in terms of crop mitigation strategies. So my second point is about modern agricultural practices. And we really are in jeopardy here, because we've bred for monogenic disease resistance, which we've deployed around the world, and we've got very hooked on the idea of single target site antifungals. So just with reference to the fungi and the oomycetes alone, if we take the case of Phytophthora infestans, which we've heard a lot about today, this is a fast cycling pathogen. It's polycyclic, it can go through a disease cycle every 3 to 7 days, generating an inoculum potential of 100,000 million zoospores per hectare per season. Insight into the genome recently published by Haas et al. Has shown that this is very plastic. The genome is littered by SNPs, by retro-DNA, and by effectors. Fast-forward evolution for the emergence of resistance to our genes and also to single-target site antifungals. So modern agricultural practices are putting us very much in jeopardy, and we need to go towards sustainable agriculture. So my third and final point is the way ahead. We need to raise public awareness to the plight of plants, not only with the public, with also politicians. I'm happy to say that the Agri-Tech strategy and Horizon 2020, for the first time, have put sustainable agriculture onto the map. We obviously need to train more people, not only undergrads, but also PhD students, postdocs, and have some natural career progression so that when us old bucks and does fall off the stage, there'll be someone to follow us. We also need to think very seriously about more balanced funding. We spend an enormous amount of money funding HIV, TB, and malaria research, and comparatively little funding plant sciences. If only we could right this balance somewhat by raising awareness to the plight of plants. For surely these diseases, HIV, AIDS, and TB, are purely academic if you have nothing to eat. Thank you.
I'm going to now pass the word to Dale.
Okay, so I'd like to start off by considering the issue of funding, and we're very privileged to have Jackie Hunter, the new CEO of BBSRC, here, and I'm sure we could sit around here banging our fists on the table and saying, give us some more money, Jackie, you know, we really need it. But I would say that actually, if we're going to make that kind of argument, what we need to be thinking about doing is not only about being defensive about the lack of funding for plant science, but actually thinking about where the opportunities are going to be in the next 10 years. Where is the vision? And I think it would be, of course, this crystal ball gazing is difficult. Who would have imagined 15 years ago that we'd be living in an era of next generation sequencing where it was a trivial, almost trivial matter to sequence a new species, and certainly a pretty trivial matter to sequence varieties once you've got a good reference genome. So where are the areas that we think are developing? Where do the opportunities lie? And this relates to funding, because I think there are two, as Jim has said, BBSRC has been a fantastic supporter of plant science, really, apart from Gatsby, the only major national supporter. And I think there are two areas that we might think about as where plant sciences can really offer a great vision and an area of interface between research councils, which can potentially open up in this era where research councils are getting less siloed with respect to their funding and where we can have societal impact. And the first of those areas I'd suggest is around the BBSRC NERC interface, where, as you know, plant sciences to a large extent at the level of fundamental research has had a strong reliance on Arabidopsis. And what we know now about natural variation from Arabidopsis in terms of its traits can now be taken out into the field, and as Tim Benson was saying this morning, in a way that we can start looking much more at G times E interactions, not only with respect to crop species, but also in the natural environment. And if you look at many ecologists, they're not living in an era of next generation sequencing. There are huge insights that we can deliver from the traditional plant science community, the more molecular science community, that impinge on that more ecological area. The second area that I'd suggest that is right for development from plant science is that area of the biomedical interface. So we've heard already how probably disproportionate amounts of funding go towards funding biomedical sciences. But we know a whole load of problems are nutritionally related. And the issue of diabetes was referred to extensively by Tim this morning, but there are a whole load of other issues, particularly in the developing world regarding micronutrient availability, where we as plant scientists can help, and where the MRC and Wellcome should also be taking an interest. And I think that these are areas where we can look actually towards expanding our funding base potentially if we make the right arguments, and not be so heavily reliant proportionally on BBSRC. I think there's a third area where we receive almost no funding, and I think this was alluded to briefly in the report, but I think it's somewhere where we should really be lobbying very hard. We can do, as British plant scientists, amazing things for orphaned crops in developing countries. There are many crops which are eaten in sub-Saharan Africa which are far off performing to their full genetic potential, and actually the knowledge base that we have here can be used to help a lot of sub-Saharan African countries. There are good programs opening up, for example, in Becker, but the Biosciences for East and Central Africa, which is in Nairobi, where DFID should really be thinking about actually putting some of their funding base into excellent UK science and facilitating more programs. They already have 3 programs, I know, going through the Royal Society, but those are not large sums of money. If I've got a couple more minutes, Sandy, could I address training and skills? I think the message here, is really, if you want to inspire a next generation of sciences, get them early. And if you look at the paucity of plant sciences in most A-level syllabuses, we're really in an appalling situation compared with the amount of plant sciences, for example, that I had when I did A-levels many years ago. So actually making and of course one gets into a vicious circle here, whereby a lot of people coming in to be teachers or curriculum setters have already specialised in zoology, and therefore think that, because that's what's mainly taught in universities, and think that's where it all begins and ends. And of course, as we know, it isn't. So make plant sciences exciting to teenagers. And then I think the issue of master's courses has already been addressed. What I'd also like to say is that in universities, it's important that curricula don't ghettoise plants, such that you have the choice of, hey, here's a zoology module, or here's the boring plant module. And actually, the way we used to the things were taught in York when I was here, and Ian will tell me if it's still the same, is if you do a development course at York, you do plant and animal development side by side, and you have really loads of interesting questions about open patterns of development versus closed patterns of development, but using many times the same motifs in terms of transcription factors and the same kind of recurring themes to give very different outputs. And then I think the last thing that I really wanted to say was I think let's not forget that we are, while national priorities for plant science need to be set, let's not forget we're operating in an international dimension. So I'm talking here not only about DFID and the developing world, but also about opportunities by which we can use UK funding to leverage funding from overseas in good collaborative projects. And for example, at the John Innes Centre, we're opening up a major collaborative program with the Chinese Academy of Sciences on the grounds that we can expand our research base at minimal cost to ourselves at a time of essentially pretty flat level funding in the UK.
Thank you, Dale. It's Mark. You said Mark now, and then you, yeah. Now I'll pass to Mark Chase.
Okay. So Kew Gardens and the things that we do, putting a slightly different perspective on this, taxonomy was mentioned as one of the areas that needed further investment, but I think many people forget exactly the importance of plant taxonomy to a lot of what we do. If you get into crop-wild relatives, which of course is becoming a much bigger topic in terms of knowing the relatives, knowing what their traits are, their distributions, what tolerances they have, and whether or not those can be bred into crop species is very important, and it's taxonomy that will inform us about those things. We also need to worry about plant conservation, that in particular, because we know from many studies, some of which were mentioned earlier today, that crop species don't do well if they haven't got some natural systems around them. There's a great deal more resilience in our ecosystems if we have biodiversity present. So that's plants, fungi, and animals. Plants are the linchpin in that whole equation. And so it's important for our crops, as well as us, for biodiversity to be present in our systems. And of course, plants, we talk about plants. What we're talking about are flowering plants, angiosperms. They're really the new kids on the block in terms of life on the planet. They've only been around for 160 million years compared to many other groups that are much older. And they, in that period of time, have come to dominate the planet like no other group of organisms that ever existed. Angiosperm ecosystems are the most complex that have ever existed on Earth. And the basis for that complexity is their great interactions with other organisms, their pollinators, their fruit distributors, fungi in the soil, each other, so on and so forth. And we shouldn't forget with our crops that these are not things that have they have this evolutionary history behind them. It's the interactions that are important in resilience. Ecosystems that are complex are resistant to climate change, and we can't forget that our crops are part of that system. When they started out, we have to relate them back to those systems. Again, arguing conservation and biodiversity are important to crops. In addition to their brief stint on the planet, flowering plants are also unique in several other ways. We don't fully understand yet why polyploidy is an advantage. In fact, it was thought for a long time that polyploidy was an evolutionary dead end. We now know that's not true. We also know that all flowering plants are polyploid in their origins. There are no crops outside of the flowering plants. No fern, no gymnosperm probably has any great potential to have done anything for us or anything in the future. It's angiosperms. And what is it that's special about angiosperms? Polyploidy. What do they retain after these bouts of polyploidy? It's not the structural genes. Most of those go back to diploid condition within just a few thousand years. It's transcription factors that seem to be retained in great numbers. And it's those that would indicate, I think, what the advantage of being a polyploid is. It's modulation of transcription, it's expression, the modulation of expression that's important. If we understand the evolutionary history of plants, then we can see what the advantages, evolutionary advantages they've had are. And on that basis, I think, again, start looking at our crops in a very different way from a completely different perspective, remembering that they are the products of their evolutionary history, and we can't divorce them from that when we're trying to improve them.
Thank you, Mark. And now I'll pass to Mike Bushell.
Okay, now she made that thing up about the 150 bottles of
No,
wine,
I
I've got to
didn't.
say. And I never saw them. Okay, first of all, I'd like to say I guess the panel's been brought together to prove to you that we have an ageing experience base here. And luckily, looking out here, there's a lot more younger people than we've got sat on the platform here. So I just want to talk to two or three of the topics. Firstly, plant science is alive and well in the UK. And it's an area, I think, which we can be justifiably proud of the UK's leadership in plant science, but also in talking about the implications of climate change and the great global challenges through the work done by the Foresight team led by John Beddington since the first recent food price crisis in 2008. Now, plant science, I think, is much higher up the political agenda than it used to be, and I think that's a very good thing. And a lot of that goes back to the leadership that was shown by John. Now, I think we heard a little bit today about the great global challenges. All I'll say is, rather than repeat all of this, there's never been a time when plant science was more relevant or more needed. Because the global challenges for sustainable agriculture for the future are massive and very difficult. And particularly when you factor in climate change, which we've heard today, is going to move us, I think, to a worse position than most of the doom mongers thought we would be at. That is going to add enormous need for better mitigation and adaptation measures, and a lot of this will come back to understanding and harnessing the fabulous power of the knowledge that we have based on genetic and genomic knowledge. And I think the future is therefore in all of your hands. So I don't need to preach too much to the converted there. But what I would say is, in the topic that's about inspiring the next generation, it's actually extremely important that all of you who are passionate about plant science actually go out and inspire younger people yourself. It's actually pretty useless, people like me going into a primary school talking about my career, because it seems so remote and different to the experience of the people who you'd be talking to. Whereas a lot of you, if you've got great stories to tell, and agriculture's full of fabulous success stories, these are what you need to use to show people not only the excitement of doing the science, but the value that's created for people all around the globe by the innovations and applying that knowledge that we've had from our fundamental science base towards real problems. Now, Sandy and I had the great pleasure about 10 days ago to be on the panel judging the BBSRC Innovator of the Year Awards. And we actually have a winner in the audience here, so I won't embarrass Kathy by pointing at her. But it was a fabulous example of practical application of modern plant science. And there were many others, which I think we can use to inspire that next generation of university students, but also to take those stories in a simplified form back into schools. Because unless kids do biology O-levels, shows you how old I am, unless they do biology at school, then they're going to be lost to the community later on. The last point that I will make is on regulation. Industry, you'd expect to moan about regulation. Well, of course we do. But regulation of agricultural technologies is absolutely necessary. And it's important because it goes straight to the safety of the food that we eat and the safety of the environment. And so effective regulation really has to take account of those factors and make sure that the safety of our food is assured. However, the point I'll leave you with is the graph that Tim showed about where all the calories are produced in the globe. And only one of those 5 areas where we're producing an excess of calories today is really unaffected or possibly, in some cases, marginally benefited by longer growing seasons under climate change scenarios. And that's Northern Europe, where unfortunately the regulations that are coming out of Europe are taking an increasingly negative view of the technologies that have made agriculture successful and delivered the safe, plentiful food supply that we have today. And that absolutely must change. And again, it's going to be a lot in your hands for the future in taking forward those arguments based not only on science, but on an understanding of the real risks associated with technologies and making sure that those messages get a hearing in the places where political decisions are made. So that's another challenge for the future for you. But I would end by saying there's never been a better time to be a plant scientist. And again, as I said before, never a time where it's been more important.
So it's left to me to have the last word, and I sort of sorted this out so that I could have the last word, and partly because I knew that all of these people would say things that I wanted to say, but would say them much more eloquently. But something I'd like to come back to that struck me about the talks this morning, particularly that which was given by Tim Benton, is this focus on variability, is about breeding for the mean versus breeding for the difference, and about site-specific agriculture and site-specific areas. And we all know that the world is complicated. We all actually, from the time of Lamarck, we've known that a seed that grows on stony ground doesn't always grow, and that different places are different. You know, one of the things that the people who discovered the New World saw was they speculated that there must have been 2 gardens of Eden because the vegetable productions of the New World were so very different from those of the Old. So we know that there's variability. We know there's variability on a big scale, but we also know by studying plants in their very inner workings that there's variability on a small scale. And so it's actually taking into account that variability, which is, as Theodosius Dobzhansky said, is nothing in biology makes sense except in light of evolution. And I would say we have to apply that same principle perhaps to agriculture and think about integrating more across plant science rather than going very deep into various areas and not paying attention to the others. So I just want to illustrate this with a story about a project that I was reviewing for the Norwegian government last week in Germany, which is a project about taking crop wild relatives and looking at them, looking at their distributions, looking at their tolerances, and then using those crop wild relatives through into pre-breeding of varieties of crops which would be useful against climate change, would be useful in scenarios of climate change in different localities. Now you think that sounds like a really great idea. What was interesting about this project is it went all the way from the taxonomy of who the crop wild relatives were. What species were there that were related to the Bambara groundnut, for example? What species are there that are related to the peanut, to wheat, to potato? Where are they distributed? And what's quite shocking is we know very little about those crop wild relatives. Most of them are known from very few spatial points, so we really don't know enough about how the relatives of these crops are distributed. They then go through, the project is funded for 10 years by the Norwegian government. 10 years is a very long time to fund a project. And that's something about stability as well, is the long-term funding, because a lot of this work takes a long time to translate from basic science through to translation into something that farmers can use in a field or can begin to adapt to their local circumstances. So I think one of them, for me, one of the most important of our recommendations from this report is that we think about a balanced portfolio of science in plant science, and we think about not necessarily every person doing every kind of plant science, but understanding it and caring about it and integrating it into projects, but that we also think about that long-term funding across that balanced portfolio that will allow us to translate from basic research into something that is useful to a farmer in his field in a local area. Now, this doesn't mean that each one of us, I'm in no way equipped to kind of pre-breed a variety of anything and help a farmer introduce it into his local field. I'm really good at finding new species of potatoes and tomatoes and things, and so I'm pretty useless at that. But I think it's by working together, not just together amongst the UK plant science community, but in international collaboration and cooperation, both across the developed world, but more importantly with the developing world, is where we can really make a difference in what we do in UK plant science. And we have a really, really good history of doing that. And I hope we don't lose it. And for me, that's one of the most important things about this report, is that we need to take that forward and stimulate that into the next generation, which is you guys. So I'm now going to go over here and open up the floor to questions, comments, people who disagree, anything. And I would like you to wait for Emily, Zakwan, or Kyriakos to come to you with a microphone to ask your question so that it can be recorded, so we can record that. So does anybody want to kick off? Oh, come on, somebody's bound to have some comment. Kathy!
I want to ask a question about the problem of funding fundamental research at the same time as pushing funding for plant science to address all of these global grand challenges. I think that if you're going to make a pitch that we can contribute, and I believe very strongly that we can contribute to solving grand challenges, I think we have to have some oversight that we actually deliver on that promise, because if we don't deliver, and if we take all the money and invest it just in doing more fundamental stuff, which we really enjoy doing, we'll never get the opportunity again to do it. So do you think that it would be a good idea to separate off the stuff for fundamental research from the stuff for solving the grand challenges? Or are we just going to sort of somehow say that the fundamental research will somehow answer the questions of the grand challenges? I think that the funding agencies they'll be unhappy about funding too much fundamental science.
Would anybody like to address that? Would you like to start, Jim?
Dale,
you all would.
Yeah, I guess these are personal things. I'd just like to point out, these are the debates that the UK PSF want to happen, so that we can actually then come out with a joint policy. One thing I say is my personal view here, right? I just think it would be a real shame to separate fundamental from translational sciences. I've never seen them as separate entities. I might work mostly on fundamental stuff, but I do it because I think I'm doing something that could make a difference in the field, right? And so I just think that would be a real shame to split the two. And it's the combination of all of the people in this room that do the different things that makes plant science effective. And if we're going to deliver it, needs that togetherness of it. I just think it'd be a shame to separate the two.
Hasn't someone once said that all science is applied? It's just that we haven't figured out how to apply it all yet.
Okay, I'll go. I very much agree with what Jim said, and I think it would be a complete mistake to try and separate into boxes fundamental and strategic research. And I think actually BBSRC understands this very well, that you don't get great strategic research without a great fundamental understanding of basically how life works. And we've just heard a fantastic example from Lars's lab where there's a complete continuum from asking a basic question about how an Arabidopsis pod, shatters its seeds, right through to something which is almost ready to go into the field. But if you don't ask the basic questions, you don't get the great strategic science. And another example at the sort of biomedical interface of things, many of our drugs are still complex drugs like vincristine, are anti-cancer agents, are extracted from plants that produce them in low amounts. In this era of synthetic biology, there's clear applications in being able to put those into some system of fermentation. But along the way, there's some really interesting chemistry to be done and some really interesting work on enzyme mechanisms and all of those basic questions that you can explore alongside the more biotechy aspects. So I think it's a complete continuum, and it would be at our peril to try and separate those.
I think it is a continuum, and I think we're all probably familiar with the open innovation models of an innovation pipeline or a funnel. And, out at the front, blue sky research, it may not have an end in sight, but actually often it's people who spot the results from this blue sky research and put it together with other knowledge they have that's, if you like, close to translation or the ability to translate, to meet a real farmer's need in our industry, that actually makes the difference between getting a great product into the marketplace and not. I would say, however, that an element of ring fencing, or at least a strategic understanding of what you're spending and where you're spending it, is actually essential. Now, we spend $1.5 billion each year, and we have a very complicated process for deciding how it is that we spend that money. And the reason that we do that is that we're not short of ideas. We could spend that money 3 times over just with the ideas that our researchers inside the company have. So, we have an allocation for research, and it's separate from development, and we decide spending between the different crop sectors that we have by actually looking to see what the shopping list of projects are, and have a lot of professional people poring over those projects to see which ones are the ones which have got a real chance of success and make a difference to our customers. Because although, we're obviously out to make profits, we become successful as a company by meeting our customer needs better than anybody else can. And that's really what you must remember in this. It's the farmer and it's the grower, and it's meeting their needs.
Jackie.
Hi, I'm Jackie Hunter from the BBSRC. So I kind of feel I ought to comment on this as I'm sitting in the audience. I too think it would be fundamentally a very bad idea to separate out those 2 strands of research for several reasons. One, we know, and it's been said, you can't predict where things that will be applied come from. Who would have predicted that working on agrobacterium in roses would have ended up with genetic modification in a wide variety of crops? Also, I see it as a virtuous circle, because if there was never any outcome from any of the research, the basic research we funded, then it would be very hard to argue when you've got resources you're taking from hospitals or schools or whatever, to make significant arguments for basic research. And my job, and those of my colleagues at the BBSRC, is to lobby government to put more money, and we can come on to that tomorrow about, that we've really got to try and make our case as strongly as possible, more money into research. And therefore, the success stories of the basic research of the past allow us to reinforce the excitement about the opportunities of the future. And you need to have that intimate connection that allows you to do that. So I think, A, we ain't smart enough to be able to divide it in the first place, and B, we can actually use it as a virtuous circle to enhance our funding going forward.
I guess we should also say that if you go back through history, you can learn a lot. And Michael Faraday, of course, discovered electricity. But actually, he was deterred from doing that for about 10 years because he was forced to work on something else. In fact, trying to make the UK or Britain more competitive in telescopes. So he was working on lenses. And actually, that work probably wasn't competitive and delayed a much more significant invention. But I would say, in terms of inspiring you all, that there's a fabulous opportunity for applied plant science to work across the boundary with lots of other exciting disciplines like modern electronics, sensor systems, drones. All of these things, we can find better ways to apply existing technologies to make them work more effectively. And all of those areas are cases where academics with good ideas can actually play a role in bringing that technology to the marketplace through startup companies or through licensing those technologies to other companies who have the muscle to take them globally.
There's a comment up here.
Yes, it's Bill Finch Savage from Warwick. I'm also in the older end of the spectrum, and I just wanted to make a comment because what seemed to be coming forward was that a little bit that this great fundamental work is then looking for a home rather than having a deep understanding of the crop science and then directing the fundamental work towards understanding what's really needed in crop science rather than... So it's just... I don't know whether I'm saying anything different from what anybody else has said, but whether or not the question's coming from the fundamental end, we're doing really nice, interesting stuff, let's try and find something useful for it, or whether or not we really want to address the issues of the limit yield, that limit how we should understand the pests and then look for a solution, not have a solution and then try and understand what the pests happened, and don't lose a lot of the understanding that we gained in the past. I come from an institute background where there was a great deal of trying to understand a lot about crops and then go to find some solutions. I just worry, listening, that, because the motivation there is now to have high-value science for good publications, and I understand that as much as anybody, but then to try and find a home for it. I just feel that the emphasis shouldn't go too far that way, but should come back the other way.
So I would just like to comment on that, because that's something that I think is really important, is it's about collaboration. Is that it often seems as though science exists sometimes in silos and that we don't talk to one another enough. And I think that's one of the strengths of the Plant Sciences Federation, is it provides a forum in which people who are looking at things from slightly different points of view can come together. Because if you think about working openly and working responsibly and thinking about responsibly innovating, you need to kind of anticipate things and think about things and include other people and then think about what they say about what it is that you do. And I think that sometimes we get very blinkered, and I mean I do it as badly as anybody else. I get very focused on my describing new species and I don't think about anything else. But some of the it's about communication and collaboration with other people, and that can be very difficult because we as scientists have learned new languages in our communities. It's like learning French for me, going to a genomics meeting. When I first started going to genomics meeting, I used to score the pad on one side, and I would write down all the words I didn't know. And they were very long lists at the beginning, and they're getting much shorter, which means I'm learning something as we go along. But I think we sort of talk to each other too much, and we need to get out more, I suppose.
Yeah, sort of to follow up on what Bill just said. So I think one of the speakers today was showing that one of the greatest sort of leaps or periods when we made the biggest gains in agriculture was right during and after World War II, when there was a real drive to focus on the things that really mattered at that moment, if you like. And so I just want to say a word for problem-led research. We were talking about fundamental, and I absolutely agree that we need a fundamental science base. But if we're facing real global problems, then I think it's very important to try and keep the problem-led aspect right there on the research agenda. And I think that's also what you need to thrust into the face of the politicians if you want to try and the people in general as well, to put pressure political system to ensure that we do get the sorts of increases in funding for plant science, that we need to sort out these problems or at least do something about them.
Can I make a comment? It's in response to Bill and also to yours, really, which is we're in a bit of a conundrum. So we've all tried to return, and most of us manage 4 4-star papers for the ref, but 4-star papers do not give us practical disease control for post-harvest storage diseases in Africa. That is impact factor 1, whereas we're all striving for impact factor 30, ha-ha. But that's what we're all trying to go for. So, and the other thing is, responding to what Sandy said, is in the spirit of collaboration, the best science is done as a collaboration, but also it is in the face of the ref, who is going to be corresponding author. And so collaboration and ref return have been really quite detrimental, in my opinion, says she very outspokenly.
I think that's a really interesting point about how we work as people, and how we pull together as a community I mean, we are a community. I mean, no man is an island. No one sits alone and does their research in a darkened room. Not even taxonomists do that anymore. I mean, even taxonomists work in big global consortia to look at things, which is actually might be shocking to some, but is in fact true. Does anybody else? Mark?
Well, I completely agree with them. I think Bill has a really good and excellent point about where do the questions come from, and how do we address them. And the issue about collaboration is, of course, a really important one. I think one of the best initiatives at the moment that PBSRC has, to my mind, is the Crop Improvement and Research Club, because that brings all these things together. It brings the collaborations, scientific collaborations, it brings the industry in as well, and it brings in also the important questions that are both fundamental, because that was part of selecting the grants, I remember, was that it had to have very excellent scientific questions as well as addressing very important questions regarding crop improvement. This club has, I think, a lot, maybe not everything, but has really a lot. And I think it's very, very important that it will continue something to that extent. I don't know if it's a crop club 2 or something, but I think it's a very important message to PBSRC that something like this should continue as well in a following funding round.
Yeah, there's a point down here, there's somebody down here, and there's another one up there.
So on the topic of variety and diversity, I mean, we all agree that training is important and that collaboration is important, but I think we also have to make sure that it's not a one-sided direction. As Dale pointed out, this extension into China is, I think, very important, but how easy is it actually to have knowledge transfer back? How easy is it to get researchers back into the UK and get knowledge, varieties, in technologies and so on and so forth back into the UK and benefit from that? And is there a regulatory framework that is limiting us?
Since you were mentioned.
Okay. Well, I can refer to that specific example if you like. That there are many aspects where it's not easy. I mean, where the examples where there are benefits to us is that it's possible, for example, very easily to do GM trials and get GM products out into China, which is a wonderful thing if you know, to see that kind of impact develop. But it's I think I was referring more to it being a kind of two-way information flow and very free collaborations at a, I guess, quite a fundamental level. But actually at the more impact level, there are definite benefits. While I've got the microphone, if I can just go back to Bill's point. I mean, I completely agree with what you're saying, Bill, that there are some questions where the driver will be a fundamental one. Equally valid are questions where the driver will be, you know, let's solve a real-world problem by understanding the biology. But many times when you want to understand those real-world problems, like the yield plateau or something, you'll be drawing on information that's been gleaned from fundamental biology, I guess. So but I didn't mean to imply that the two approaches can't go hand in hand, and indeed I think they should.
There's a comment.
Can I just add one or 2 points to that? I think, you know, as a plant scientist, thinking about agriculture is the world's most international business. It's done in every country in the world because everyone is eating food every day. It's one of the two commodities we all need every day. And actually, British researchers have got a fabulous track record about taking leadership positions all over the globe in this area. So don't think only about the UK. We've got 28,000 employees. About 5,000 of those are technical R&D people all around the globe. And a large portion of those in leadership positions are Brits in very many far-flung corners of the world. I think on the applied versus fundamental area, the nice thing that I see about modern plant science is that a lot of things which historically were questions we couldn't even hope to address are now possible to do using modern technology, particularly aided by next generation sequencing, and understanding how those fundamental plant processes work, because there's such a large syntony between all the different plant genomes. You can very quickly go from a model plant, or indeed a model crop plant, and look for those same processes in the crop of interest. And actually very quickly turn that knowledge into markers for breeding and improve plant breeding programs in real time.
There's a comment here. Yeah.
I'm quite fortunate because I managed to get a placement at the Botanic Gardens in Wales for my sandwich year. But it was through 6 months of applying for things and hassling people and emailing people. And you're saying that you want to encourage the younger generation, but how can you do that as a community when so many people aren't willing to fund such positions? Because it's not like we're expecting that much. I think most people I know would just be happy if they had enough money to cover their expenses for the year. Because it's been so important to me to get that experience and learn in an applied environment and be around new people learning ideas. And I've got other friends who would have wanted the opportunity, but they weren't prepared to stick it out for that 6 months of applying and writing people. And having so many rejections back going, yeah, we'd love to have you, but we don't have money. And you can't be expected to live on nothing, even if you love your topic.
That's an incredibly good point, and I think it's really good that one of you next generation researchers has said, you know, what it is that's eating you and what it is that can help you, because I think we'll never solve plant science in the UK until we actually listen to people who are the next generation of scientists. And here's another one.
Hi, thanks. Well, one of the things you were talking about earlier about, obviously, sorry to drag it back to that, but fundamental versus applied science. Well, for doctors and professors, yes, you want to have high impact papers, but for young people starting out in their career, you really do need a high impact paper, particularly with such competition for jobs, that an applied PhD can be a career death sentence almost. So I was wondering, how do you balance this need for more academia to focus more on applied versus the realities of how academia works in terms of its internal structure for deciding who gets jobs and who doesn't?
Celia probably has something to say about that, and then I'll come to you, Jim, okay?
Well, related to the previous one as well, and I had wanted to raise this question about what does this audience think about internships, because my own experience, and has been mentioned, this is the best time for plant science now, and we know from the experience of the Gatsby Summer School students, they want to know how to experience a taster of what might be out there. Now, internships, the sort of placements or the second year undergraduate summer studentships are peanuts, really, financially. A couple of thousand, 2,000-3,000 per studentship. If we can place those strategically and make that raise the awareness of those opportunities, I think, and perhaps we can hear from some of the audience here, the young people would really jump at those, because they not only get to see whether plant sciences is for them, they gain a fantastic array of transferable skills. And it's as important that some of those go out with that experience of the needs of plant science, possibly into other careers as well, in terms of disseminating some of the issues that plant science has. So my question is, what does the audience think here about the possibility for more internships for a work-based learning?
Should we have a vote? We can have a vote. No one over 40 is allowed to vote. Okay, all under 40 who think that that would be a good idea, raise your hands. There you go, that's pretty overwhelming. You can't vote, Celia. Yeah, there's somebody right there.
It's Jim Murray, Cardiff. I wanted to raise an issue actually quite closely connected with the points that are being made around undergraduate training and the interplay between the important undergraduate training and funding for research. And I think this is something that perhaps doesn't get considered that much by BBSRC, of whom, incidentally, I'm a great supporter, but...
You have to be. Careful.
Having had the luck and the privilege to have been continuously funded by BBSRC since they came into existence. So, thank you. But the point is this. All our plant scientists go through university courses. They need to be trained by academics who have experience and expertise in plant science. But university departments won't hire those people if they don't think that they have a good opportunity to raise research funds. So in most biological sciences departments are interdisciplinary. They cross the whole of biological science now in universities. So you're a head of department. Do you recruit somebody who's doing biomedical-related research? You can go to a range of charities as well as the research councils. Or do you recruit a plant scientist who's more or less limited to BBSRC? And I think this just highlights the key significance of responsive mode funding, where most plant science funding comes from BBSRC. And this is absolutely critical to establishing the framework that we need to train the undergraduates who are going to be the plant scientists of the future.
It's interesting because a small aside is that I serve as a referee for many NSF grants, and the National Science Foundation has particular sorts of funding which are directly directed to undergraduate training, and you basically can't get the grant unless you include the undergraduate training, and it's science that it's every bit as good. So it's somehow we've missed a trick. Right there.
I just want to talk about internships again, from what we were saying, because sometimes it's not always about money. In our department, we were offered to get a fully funded internship wherever we wanted to go for 3 months. And actually, I was one of the only people who wanted to do it. And that's because people perceive that there's too much pressure. They don't have enough time to go outside of their PhD to do this. They don't have enough, they don't want to ruin their research career. And actually maybe we should start looking at the pressures, the mental pressures that people are being put under, that they feel like their PIs don't want them to go out and experience this. They feel like they want them to stay in the lab and increase their research.
That's something that we look at when I serve on a BBSRC panel, strategy panel for biosciences and society. And when we first started implementing the impact agenda across the BBSRC, one of the things that we found was that sometimes early career researchers were discouraged from doing public engagement by their PIs because they felt that that would negatively impact upon their research. Whereas actually public engagement, I mean, I come from an institution which is all about public engagement. I mean, who doesn't know there are dinosaurs in the Natural History Museum? Okay. We actually do more than dinosaurs, but never mind. Public engagement is how you get people to listen to your stories, because all the science we do is a story. And we can tell politicians until we're blue in the face about how important we are, but until we capture their imagination with a story, they're not going to listen, because it's the capturing the imagination of someone that really gets them to listen to you. I mean, you think about it at a party, when you have a bore going on at you about something all the time. Do you want to stay and listen to them, or do you want to go find somebody who's telling a really good story? And you can think of that, the politicians are the people at the party. There here in the middle. She's got the microphone. She gets to go.
So first of all, I actually went to the Gatsby Plant Summer School and really enjoyed it, and that was one of the times that I started really enjoying plant science. So I think those things like that are really, really important. But another question that I had to the panel is that you've talked about inspiring new generation, and that really starts from secondary school and primary school. So I just wondered what you were doing to try and change the curriculum, because like I said, my plant science inspiration came at a later stage at university, and there was just nothing at primary school and secondary school that was really inspiring children to get involved in plant science. So I just wondered if there's anything you were doing.
Hi, my name is Anna. I'm actually here as part of my PIPS internships. I had 2 points. First about internships. I think they're actually an excellent way to get experience in the plant science world, or in science. And I'm basically a BBSLC funded PhD student, and as part of the PhD we actually have to do a 3-month internship, and it's one of the reasons I chose this PhD. So I think it's an excellent opportunity, and also helps if you have maybe problems with certain supervisors that may not want their students to do an internship. I think it's actually a really excellent scheme. With helping with biology in schools, I'm also a STEM ambassador, so I'd really recommend that you do that as well, because you can go to schools and talk about what you do and encourage other students to do plant science as well.
Can you give Can you just give that microphone to Jackie up there? Having only one microphone is really bad.
And there have been a number of PIs who actually have said they aren't supportive of these 3 months outplacement. I would urge everybody to try and be as supportive, because they are training, right? It should be a well-rounded training. And, actually 3 months, I think, doing something different, but adding to your skill set is really important. So I am actually very supportive of those 3 months placement. I think they're a very good idea, and also broadening and getting credit for things like public engagement.
I think one of the points that woman here that was just brought up, I think that's critical, and one of the working groups we want is in that, So actually, if you have good ideas, that's a key thing to contribute to. I mean, people here, Ginny Page is here from SAP, so I mean, these people, there are groups here who are working actively in trying to change plant science education in schools, but we agree with you, and I think from the working groups from UK, to me this is one of the key ones, is what we could actually do to get curriculum changes.
Yeah, because there's one aspect of us going in and talking to them, and like you said, I'm a STEM ambassador as well, and I've gone into schools and talked, but what's actually in the curriculum and the teachers are trying.
The Gatsby Foundation has that SAPS, which has really been important.
Hello, I'm Ginny Page, with Dan from Science and Plants for Schools. And we do many things, one of which is talk to those who develop the curriculum. You'll be delighted to hear that there is new curricula going in place from September onwards, right the way from primary through to the end of secondary. I'm afraid teachers aren't so delighted, but it's a massive amount of change, and I think we need to be very careful what we expect teachers to do. We can change the curriculum, but we change it at our peril if teachers are not excited and informed in then using that to engage their students. But I would say positively, the curriculum is not as bad as you think it is. It does actually allow quite a lot of teaching about plants. It's just that teachers themselves don't have that knowledge to do it. So don't assume the curriculum is always the answer. We produce a lot of resources for biology teachers that show that you can teach exciting biology through plants, and I think that's the most important message. I would also say that the work that you do on outreach and engagement is really important. You show students and teachers that there are exciting stories, as Sandy said, although I think we have to give some of them a happy ending. And I think with food security, we're very good at talking about the doom and gloom, but we need to provide some happy endings at some point so that the new generation can believe they've got something to contribute and solve. And I would say for all those PIs that stand in your way, remind them that there will not be PhDs and postdocs for them in the future if they do not allow you out to encourage and support them.
Ian.
wanted to make a couple of points. The first is the risk of sounding complacent. Responsive mode funding success rates at BBSRC are still pretty good compared to all the other countries that you consider as our competitors, as it were, for plant sciences, and it's something that we shouldn't forget, and we should, So I think it's really important to get that message out to young people thinking of plant science as a career, that it's still, 20%, 25% success rate at responsive mode funding at BBSRC. And, tell me another country in the world that has got that success rate for one of its main funding streams. And the second thing is that we just don't rely on responsive mode funding from BBSRC for it anymore, and I don't think that's necessarily a bad thing. If you think of industrial biotechnology, which I was mentioning this morning, it's, plant science is all over it, and there's £45 million this year in industrial biotechnology funding available for plant scientists to compete for. And a lot of that is down to biochemistry and enzymology and metabolism, as well as transcription factors and gene expression. And so I think it's important that we don't get obsessed with these fixed figures of monies that are available for plant science. And Jim, you mentioned, you showed a figure of 70 million and 25 is available for plant sciences. I think we have to be, and young people coming into plant science have to be creative in terms of where the money is available and where their good creativity and skills can be applied. It's at BBSRC, but it's at DFID, and it's with industry, and it's with charities. So I think there's plenty of opportunity, and Jim Murray was making the point about we can't appoint plant faculty if we can't demonstrate that there's funding available, but there is. I know at York, for the last 50 years, plant scientists have been among the most successful at bringing in research income. So I think it's important that that we don't get bogged down in the sort of negativity around the funding opportunities available. I think it's up to us to be creative about A, how we sell the message, and B, how we go out and engage with the community to make those differences. There's one thing though in terms of the training. I think it was mentioned a couple of times about master's programs, and there's quite a seismic change going on with masters teaching and training in the UK at the minute. And just about every university in the country is moving towards integrated masters, which is essentially a year added on to an undergraduate degree, and people go out with masters after their names. And it doesn't give the same opportunity for that specialisation in a specific area, which master's programs traditionally, a one-year master's has done. And when we now in the university system look at how sustainable those specialised master's programs are, we're relying on overseas students generally to come in with their own money to keep them going, and the numbers have fallen through the floor due to the changes that we've made in pushing funding into PhDs rather than masters from the research councils. So if there's one thing that I think that we should look at in terms of going forward and getting that switch into a specific discipline, and you mentioned a number of the disciplines that were important, looking again at that master's funding, I think it was a big decision to essentially shift away from those dedicated master's programs in the UK, and it could have big implications for specialising people out of undergraduate degrees in the future.
Kathy had something to say, so go ahead, Celia.
Well, I've got the microphone. Can I just make that point of clarification about internships, because I appreciate that people may be pitching in at different levels of this. So internships, of course, can be part of the postgraduate programme, but they are also important as studentships in an undergraduate programme. So let's be clear what we're talking about when we're talking about internships.
Okay. Kathy.
So everyone else seems to have been advertising their own organisations, so I want to give a plug for another evangelical plant science initiative, which is teaching tools in plant biology from the plant cell. So anyone having difficulty teaching plant biology, We do a whole range of lectures that you can tailor to your own needs on all topics in plant. They're fantastic. Just download them. I still find people all over the world who don't know about them. Come on, go to the PlantSci website and take a look. And they're suitable. Some of them are suitable for undergraduate teaching. They're mostly third-year undergraduate level, but some of them are suitable for school teaching as well. Why Study Plants is absolutely fantastic, and you should get in contact with Mary Williams at the University of Glasgow if you want to know more about it.
I'd just like to make one comment about younger children. People my age have often had younger children who are now older children. And I read a recent report from the University of Washington, which was bemoaning and this is a report across the United States, looking at the lack of natural history teaching in primary schools and secondary schools. And many people get turned on to biology, whether it be plants or animals, but turned on to the natural world and to organisms in general. And let's face it, crop plants are organisms. Agriculture is all about organisms. It's about organisms in an environment. And they get turned on to that by their exposure to natural history as children. And if we no longer go on field trips, we no longer do dissections, there's a whole set of things that we don't do anymore. That then, I think, is something that kind of undercuts the wonder at the natural world, which is behind a lot of us in this room's kind of the reason why we went into this is not because we want to necessarily be, I mean, when you're 6, you don't think about the fact that you're going to get a paper in Nature, do you really? Or let's hope not. But it's that natural history thing. And one of the things is, I mean, one of the advantages of being kind of, on the kind of graying spectrum of biology is that you see pendulums swing back and forth. And when I was first doing my undergraduate degree was the time when molecular biology was becoming more and more important. And now the pendulum seems to be swinging back to people being more interested in organisms again and thinking about organisms, the kinds of stuff Sarah does about how organisms respond to climate change. Yeah, there are genes in those organisms, and we think about the genes and we think about how they might be impactful. But what we're really thinking about is organisms. So that comes back to my point about this report is that the balance of the portfolio and the integration across the biology is almost more important than the biology you do. Emily.
So I might just steal the mic myself for a minute. Excellent. So sort of directed towards Celia, Ginny and Dan. Just thinking about inspiring the younger generation through inspiring teachers. I know you've had huge success with inviting teachers as well to the Gatsby Summer School and had fantastic feedback from that. I was just wondering whether you thought any teachers would have an interest in visiting labs locally to them to see what type of research is going on locally, whereas it might be difficult to bring in a way of getting them excited and talk about more and also research locally.
I will pass over to the others, but certainly the more those local links can be set up, the better it is. So.
Hi, Dan Jenkins from SAPS, Science and Plants for Schools. I work quite closely with the teachers, and they're often crying out for new ideas. They like the stories, as Sandy was saying earlier. They really like these stories, which allow plant science to come alive in their classroom. They're quite often not plant scientists by background, so they're relying on textbooks which don't embellish and give the nice little anecdotes or little bits and pieces which brings their teaching alive. So they quite like to go to open days at research institutes or universities or wherever you're based. So if you're able to make sure you're present in those events, you'll probably have a really keen audience to work with.
Yeah, I said in my talk, Adam Price from Aberdeen, that I'd recently taken my BBSRC project out into primary schools, and it was a fantastic experience, really, really enjoyable. But I do feel this sort of challenge that me on my own cannot change the tide of a lack of interest in plant science. And I think what some of these people are saying is right. What Aberdeen University want to do is get the secondary school teachers into the university, get the academics to enthuse the teachers and give them a type of exercises, tools and experiments that the teachers, because there's so many of them, can actually take the interest in plant science to them. I think it's a challenge, though. quite a challenge.
Hi there, I'm Charles Lane from the Food Environment Research Agency. I think one of the things I find really interesting is the way that we value science. So predominantly you've got a panel here and a group of academics who are judged by their academic output, and that's where the funding comes from. But actually we need to think about what do the citizens think about our science. That ultimately they're the taxpayers who provide the money. And then secondly, you've also got the potential employers and industry as well, because ultimately, again, they will provide the opportunities that will attract people in. So I think it's just thinking, how do you manage that, the citizens and the employers against the academic needs, but also the money that comes with it?
I think to me, that's a really important point. We all pay our own salaries, essentially, in taxes, wherever we work. And so you think about, how am I going to sell my science to my gran? If Freeman Dyson can explain particle physics in 3 minutes to someone's grandmother, we ought to be able to explain the science that we do in 3 minutes to someone and make it really exciting. And that requires something that's quite scary sometimes, which is actually listening to what people tell you they want you to do, which as an academic scientist you wouldn't consider listening to what people, someone on the street might tell you they want you to do. But actually I can tell you that from doing public engagement for a long time, it's amazing how you change the way in which you frame your questions and frame your science because you've talked to someone who's not just the same as you are. So that responsiveness, that scary thing of thinking, oh my gosh, the public is going to tell me what to do, that's not what it's about. It's about listening to someone else from a different sort of background from you, talk about what it is you want to do. And I'm going to give the microphone to this person here. And that way we can do opposite sides of the room, Emily.
Thanks. We've been talking lots about inspiring a new generation, and sort of a lot of that debate and sort of a lot of the comments have been sort of about younger children and undergrads. I guess my kind of, not my question, but the point I'd like to kind of make sure we kind of keep in mind is, now that you've got me as a plant person, what are you going to do with me? It's kind of that sort of idea of, I'm doing my PhD, and maybe it's because I've only got sort of a few months left in the lab before I have to start writing up. That is very poignant to me, but it's like, what's the next step, and how should the plant science community support people who are making that next step and who are hopefully becoming the next generation, or the more current generation, maybe?
Well, there's a challenge. Anybody have any ideas about that? She said, looking around hopefully. I think there's one right over here, Emily, not Celia, but further in, because you've already spoken, Celia.
Others, and I'm quite a rare species, I think. I am actually paid, admittedly part-time, by the University of Reading to teach plant identification and also survey skills. The other part of my job is as an ecological consultant, and one of the areas where some of these skills, which haven't been mentioned hugely, but are also important in this whole continuum of plant science, is being able to identify things. And I'm interested about students who can identify plants, particularly the UK flora. But there are jobs in ecological consultancy which require these skills, and we don't teach them. We don't have the undergraduate programs that teach botany, such as I learnt back in the 70s at Bangor University. So really what I wanted to say here was that I have a poster with my colleague Alistair Cullum. It's a small poster out there, so it'll be easier for those of you under 40 to come and read it. And I would also be very keen, because it's all about inspiring the next generation. It's just what we do at the University of Reading, and it's very much focused on taxonomy and plant identification. But I'd be really keen and interested if people would come along and help ideas. I've actually been inspired. I came here a little bit jaded, to be honest with you, and I've been quite inspired. I've heard the word inspiration a lot, which doesn't mean, but it's nice to hear it. I've also felt some optimism. I'm not sure that's necessarily where we should be, inspired and optimistic, but I'm quite happy to be there. And I would be very keen to take some of this discussion about how we do this. I think the hottest point there for me is how we inspire the next generation all the way through. So I've been delighted to hear the points made, because there's a lot more going on than I realised. And I'd be happy if you come to my poster and we can have a bit more of a discussion later. So thanks for that.
Thank you. We're nearing the time of the end of the session, and I hate to do it, but I'm going to give the microphone to each of my panelists in turn, in case you want to have the last word.
There are a couple of things maybe I want to say to the person who said, "What are you going to do with me?" I mean, I think the wonderful thing about a PhD, isn't it, is it helps you to helps you to think how to solve problems. So actually, you don't. It's a doctor of philosophy. We kind of sometimes forget that. So actually, you are presumably well trained in thinking and problem solving and that. But there are also incredible opportunities out there, I would say, in the plant field. Not only as the traditional route, the postdoc, but with plant breeders, for example, or larger industrial companies. I think the other point I wanted to make, and it's one that Celia and Gatsby are more qualified to talk about, but I'll just give you an anecdote about inspiring the young generation. We in JIC run a summer school for undergraduates every summer. We have 16 places. We run it over 8 weeks. And in a typical year, we get 500 applicants for those 16 places. So we are turning away masses of people. And I think that besides the notion of inspiring people, clearly people are inspired, we need to think about capacity building for those people who are already inspired. And we get some funding from Gatsby for that, we get some funding from learned societies, but actually the bulk of that we pay for from our own funding sources, and which we see as a valuable contribution to the community. But it would be helpful, I think, if when the Plant Sciences Federation sort of develops its thinking, if it actually thinks about how to develop those who are already inspired.
I was going to make a very similar point to Dale. I think, don't think of your PhD as a very narrow specialism where, as a specialist, you're digging a very, very thin trench, very, very deep. Because actually, when you come out of that academic environment, then you move into let's say, an industrial world. Nobody teaches the sort of jobs that our scientists do. And in fact, the jobs that our scientists do are totally different to the environment when I joined the company. I mean, how many computers do you think ICI Agrochemicals had at Gillett's Hill when I joined? Who'd like to give me a number?
2!
And the answer was probably half a dozen Commodore PETs attached to specialist bits of kit. We didn't even have a mainframe computer. That was down at our commercial site. No secretaries had computers. So, if you don't take the view that your career is an exercise in lifelong learning, then you will become out of date and actually fairly useless for anything quite quickly. The great thing about plant science is it's moving at a tremendous rate, but actually if you've got the basic understanding and the ability to grasp the key bits of the modern science that comes along, you'll be able to play a fabulous contribution to almost any area. And one of the things that, of course, all of our projects have as a sort of a feature is that they're multidisciplinary by their very nature. They involve biologists, chemists, formulation scientists, agronomists, people in field stations who know about statistics and statistical experimental design. Because unless you have all of those people working together, you can't succeed in either a plant breeding program or developing a new crop protection chemical, or bringing in the other technologies to create a whole growing system for farmers. And a lot of that is about transferable skills. It's your innate ability to piece together stuff in a project and actually make something happen quickly. And stop doing things that are going to fail as quickly as you can as well. And these are personal skills, transferable skills, that every one of you doing a PhD or a postdoc should be picking up without even knowing it. So focus on getting the best result you can in your project, and then focus on understanding the skills that you've got and finding ways to explain those powerfully to people who are going to employ you in your next role.
And I guess I'm just going to go back to the fundamental versus other science and harp on that a second more, because I think Lars's talk was a great one of relating the history. If you don't have people who know the history and can bring those threads forward into the modern period with our techniques we have today, I think we're going to just have to reinvent wheels that we wouldn't have to otherwise do. I don't really want to see these things as fundamental science and applied science or any of the other categories. it should all be integrated across the board, otherwise we will have to reinvent things.
I mean, a couple of points. I think thanks, Mike, for that reply, because I think the gentleman down here is unfortunately gone now. Didn't get a direct reply to his question. I did a practical PhD. What can I do with it? In fact, as you say, it's the skills you've learned. It's those, and then market yourself to the potential employers who are out there for your skill base. And also to pick up, I guess, the point that Ian Graham made there. This is definitely true. That, that in terms of funding, in terms of the plant science community has shown itself to be highly adaptable to opportunities that have come up over the time. I remember systems biology people have said you can't do it in plants. It ended up being a lot of funding going in that direction. Synthetic biology has already been one big centre in plant science, and hopefully more. And so there is an adaptability and a responsiveness in this community, and I just think we want to gather that energy to go forward and things like that. And I guess from my perspective, UK PSF, thanks very much for a really dynamic debate this afternoon. It's really encouraging, and I hope you all contribute in the next few months.
Sarah gets the last word.
Thank you.
Woohoo!
So I just want to make a comment on inspiration versus retention. I think it's fairly obvious what we need to do to inspire the next generation. But referring to the issue of retention, we have a real issue. Universities have been very creative, dividing their doctoral training awards to support more students by part funding. Where they have not been creative is after the postdoc position. How do we create more fellowships to retain the good and the excellent? Because at the moment there are so few fellowships funded by the Royal Society, the David Phillips. We just don't have enough philanthropic monies going into fellowship support. And I think that's the real glitch before people get their lectureships or whatever.
Thank you, Sarah. And I would just like to reiterate that it's been a fantastic debate, and thanks everybody for participating, and particularly you guys who are at the beginning of your career for really letting us know some of your concerns. But actually, I'd like to ask you to help as well. And these, I put these up, Jim put these up earlier. These are the working groups which the Federation is pulling together. One of them is on training and skill. Well, these are ones we thought of, and if you think of other ones, man, tell us what they are, because that, training and skills, translation, funding, regulation, and portfolio balance. And if you want to talk to anybody about that, the people from the Federation Executive are here. And if you're interested in participating in any of these, and some of you had some really good ideas about things that could happen, and what we want is we don't want the UK Plant Sciences Federation to be 5 men in a smoke-filled room. That would because I'll of course have to leave because it's too horrible to contemplate. But we want this to be something that's about the community. So this is not about 5 people deciding what it is going to happen in the future of UK plant science. This is about UK plant scientists grasping those reins and deciding what do we want our future to be. And so I'd urge everybody who wants to please participate in these working groups and really get involved in the discussion. And thanks ever so much for staying for such a long time. Thanks a lot.